Okay, just two examples of surface area and volume. Again, for your review if you're needing a little bit of help on tonight's assignment. So here, the first one, find the volume and surface area of an isosceles triangular prism. It's called an isosceles triangle. Isosceles triangular, so that means the base, that's telling me what it is, that the base is an isosceles triangle, and it's a prism, so that means it's a C and P flat top. So that should help us know how to solve this. Find the volume and surface area. Let's find surface area first. So to find the surface area, I need to find surface area, I need to find the lateral area, and then I need to find the area of the bases. And we'll add them all up to find total. Okay? So let's find my, so this is finding surface area here. Alright, let's find our lateral area first. Remember our lateral area. Our lateral area is perimeter of the base times the height. Remember, that's a big long label. If I were to break this into its net, it would look like this. That's what the net looks like. And the lateral area is really this. This is the lateral. And that lateral area is just the perimeter. The perimeter, that's the perimeter of this triangle, is this distance, perimeter times height. Right? So, that's my perimeter. My perimeter here, the perimeter of the base is 10, 10 is 20, plus 12 is 32. 32 centimeters. My height is 40 centimeters. So my lateral surface area is 32 times 40. Okay, that's my lateral area. Now let's find the area of my base. Find the area of my base. It's a triangle, so it's 1/2 base times height. Since it's isosceles, I know that the height is going to bisect the base, so that makes this 6. That makes that 6, and that's 10. We've got a nice 3, 4, 5 triangle. So that's 3 times 2 is 6, 5 times 2 is 10, 4 times 2 is 8. That height is 8. So 1/2 base times height is the area of the triangle. And that's going to be 1/2 times 12 times 8. And that's going to be 48. So I've got 48, and I'm going to, since I've got two bases on this, I'm going to multiply that by 2. I've got two bases. I've got this base over here, and this base over here, so I'm going to double that. So if I were to pencil in here, what I have found, 32 times 40 is 1,280 centimeters squared. And then for each base is 48 centimeters squared and 48 centimeters squared. So if I were to add all of these up, I'm going to take 1,280. I'm going to add that to 48 twice 48, which is 96, to get a total of 1,376 centimeters squared. Okay, so there's a lot to keep track of with surface area, but C and P flat tops are very nice because that lateral area That lateral area is perimeter times height. Okay, so you'll want to remember that. Well, let's go ahead while we're at it and find the volume. Since it's a C&P flat top with the base that is a triangle, I'm going to take that area which I just found. So the volume equals area, the base, times the height of the prism. And the height of the prism actually is on its side, so it's this length here. That's the height of the prism. So I already found that to be 48 centimeters squared. Multiply that by my height, which is 40 centimeters. And I take 48 times 40 to get 1,920 centimeters cubed. So there's my volume. Okay, let's try another one. Okay, we've got a fish tank here. Find the surface area and the volume of the fish tank. Well, here's a nice application, I guess. The surface area, well, that tells me the glass that's required in order to build this, and the volume will tell me how much water it will allow. So you can see there that the dimensions are given. We're ignoring the cabinet. The cabinet's not in question here. We're looking at this figure here. Now, hopefully you can make sense of this drawing. Actually, this is a corner aquarium. It fits in the corner. So this is it is a C&P flat top, but the base of this, if I were to look from the top view looks like this. And that's a pretty poor drawing. Let me try that again. The top view looks like this. Okay, let's go ahead and put our dimensions in. So looking straight down on the tank, this is 18, this is 20, 18, and then it's 25 inches high. So if I'm going to find the surface area of the glass, well, let's look at the lateral area first. Lateral area is equal to the perimeter. So what's my distance all the way around? If this is 18 and this is 20, that must mean this must be 38. If this is 18 and 20, this is 38. So my perimeter, my lateral area, is perimeter times the height. So I've got 38 times 2 plus, well, I guess it would be 38 times 4. This will be 38, 38, 18 and 20 make 38, this 20 and 18 make 38, so that is 152 inches squared. I'm sorry, just inches, perimeter is just inches. Multiply that by my height of 25 inches. So multiply that by 25. And I get 3,800 inches squared. Okay, so there is 3,800 square inches of glass that needs to be used. Then this aquarium also has a base. I'm only going to include one base though, because it's got open lid. But the base, clearly we have to have a base so the water doesn't escape. And the base is going to be the area of this figure here. So we can kind of subdivide this. 18 times 38 is 684 inches squared. And then that's a 300 and 60 inches squared. So for a total base area equals 684 inches squared plus 360 inches squared, for a total of 1,044 inches squared. 1,044 inches squared. So the total area, surface area of this aquarium is the sum of the lateral area and the area of the base, 4,844 inches squared. Now, notice that I only used one base in this application because the aquarium has a bottom but not necessarily a top. So that would answer the question about glass, if I wanted glass in all of those places. How about volume, so I know how much water this holds? Water is going to be the volume. So since this is a C&P flat top, my volume equals the area of the base times the height. We already found the area of the base right here. So it's 1,044 inches squared, and we're going to multiply that by how tall it is, which is 25 inches. And so my volume is 1,044 times 25. 26,100 inches cubed. Now, that's a lot. Let's convert this just for giggles. Let's convert this into cubic feet. So, how many cubic feet is that? All right. Well, 12 inches equals 1 foot. How many cubic inches equal a cubic foot? Now, don't be too hasty and say there's 12, because there's not. Okay. Remember that this is cubed here. So, if I have a cubic foot, here's my cubic foot. And in that cubic foot, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 inches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 inches. It's a 12 by 12 inch box makes for a cubic feet. 12 by 12 by 12. So that's 144 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That way, there are 12 to the third, or 1,728 cubic inches. So 1,728 cubic inches is 1 cubic feet. Okay? So we have to be careful with those conversions when you go between the dimensions. So I'm going to take this value now and divide it by 1,728. So to get that, I'm going to take 26,100 inches cubed. I'm going to divide that by now notice my units. This is my conversion multiplier. My inches are going to cancel. As I multiply straight across, that's multiplied by 1 divided by 1728. So 26,100 divided by 1,728 equals 15. Run out of room here. I'll write it in here. 15.1. Where's my phone? Looks like I've got to go. 15.1 cubic feet. And with that, we'll call it a night. Good night, everyone.